You can also check out Ben Spokes was interviewed for the Number File podcast, like our next guest, Katie Steckles, also interviewed by the man. Hiya.
Hello. I thought I would just appear suddenly when my name was mentioned. That seems to be the way that this is happening. Yeah.
Hi. I think my adrenaline is slightly getting back to a normal level now. I'm assuming yours has been spiked all last week.
Pretty much, yeah. I mean, you were put on the spot there by Ben when he was like, "Tell me what card this is going to be." Like, that's surely impossible. Turns out Matt is on your side. Yeah, I'm kind of. I think I'm just sort of pushing through now. Like, if I stop doing anything, I feel really tired. So I'm just going to keep doing stuff. And that will probably keep me going until 9 o'clock.
Well, it's as I said about week sort of. I'm looking at this as a kind of a 400-meter race. We're now 67 meters to go in the 400-meter race. Right. We're getting there.
That's good. Yeah, I could run 67 meters, probably. I mean, I'm wearing slippers, so probably not. But yeah.
Yeah. So how's this been going? Do you feel it's been?
I think it's been really good. I'm genuinely impressed at what we've managed to pull together, given that we only had a few weeks to kind of collect all of the people. We sort of, because we were going to try and line up with what Mark Watson was doing, and we didn't know exactly when that was going to be until he announced the dates for this, which was probably less than a month ago. And then some of us were on holiday, and like it kind of all got pushed back. So we basically ended up with about 3 weeks to try and contact everyone and get everyone on board. And everyone's been absolutely fantastic. People have just been like, yeah, I can do that. Here are all the times I can do. And so many people just put yes in every time slot, which is terrifying. But we managed to find an arrangement of times for everyone that everyone could do, and that wasn't too much work for people. And we've had so many volunteers, and it's absolutely fantastic to see it all come together. So, yeah.
Right, you're getting a lot of love for multiple hats again in the chat. So do you have a trick for us?
I do. I have a nice little trick, and this is a thing which, if you've seen any of the videos that I've done with Numberphile, I think I've done a video about this for Numberphile, but I think it's such a lovely trick, and I want to show it to people anyway. And it's one of these, it's what I would consider to be like a proper magic trick, in the sense that if you go into a magic shop, you can buy one. You know, sometimes you get these things that are just a specialist piece of kit just for specifically doing one trick. And it is this little set of metal rods, I guess. So you can get them in different materials, and these ones are quite a sort of satisfying metal. So they're quite weighty and they're quite satisfying. And they are called mental logs. And they allow you to do some slightly impressive arithmetic feats, I guess, sort of mathematical feats. So what I might do is I might pop these on my desk cam there. Oh, look at that! It's the donation link over there on the bottom of my screen. Fantastic.
Oh,
so yeah, so I've got 4 of these, and I guess you can probably see that they are 4-sided, so that each one of them has got 4 different faces, so I can turn them around. And I've just kind of put those down, however, but I want you to be in charge of how these are arranged. So I'm going to say, if you want to change the order of these at all, you can do that. If you want me to rotate any of them to the left or to the right or twice or whatever you want, please choose a combination of alterations to make to this, to put your own mark on this, to claim this as your own. What would you like to do?
Can you swap the 2 outside ones around?
So swap the 2 outside ones like that.
And so I want to keep the 2 in the middle the same, because it says 42 and I'm a Douglas Adams person.
That's a good reason, yeah.
So can you rotate the one on the right just once round clockwise?
Clockwise, so that's that way, I guess, looking at it from the top. Is that what you meant? That's good.
Well, that's got a nice sort of symmetric feel to it.
It's become increasingly 42-y, hasn't it? Excellent. Okay, so that is our final configuration. Are you happy with that?
I'm happy with that.
That's definitely been your choice. So if you have, I'm hoping you've got a calculator somewhere.
What I'd
like you to do, if it's not also fallen on the floor along with the camera.
No,
you dig out a calculator.
It's there somewhere.
Okay, so I don't want to see your calculator.
I've turned my video off, that's why.
That's okay. Well, I don't want to see what comes up on your calculator, because I want to I want to try and see if I can beat you. So I'm going to try and race against you, adding up these numbers. So you can see we've now made four-digit numbers. So the top one there, 4,422. And I want you to add those four numbers together. So just perform that sum on your calculator. And when you finish, say, OK. If anyone at home wants to have a go adding these up as well, you can see if you can do it faster. The answer should be 22,751.
That's what I've got.
Is that right? Good. Yeah. So, I mean, that's quite impressive, right? I can add up four-digit numbers on 3 hours sleep. I mean, this is even more impressive given the state I'm in right now. But, this is obviously interesting. There's some maths going on here. I can try and do another combination. So I might pick these up and give them a proper shuffle, like a roll of the dice, and pop them down again. Are you happy with that? Do you want to change it at all?
I'm happy with that.
Okay, so do you want to add those four up? So we've got 2,377 and so on. Okay, and if you've done that, you should have 23,467.
I have, yeah. That's
right. There you go.
Yeah,
this is interesting, isn't it? So these are like, there's obviously something interesting going on here, and I guess if anyone has seen the other video that I've done on Numberphile, I'll pick this apart a little bit, and I'm going to leave it with people for a little while to have a think about, because I'll put those down there so you can have a look at them, see if there's anything interesting. I might turn a couple of them over so you can see some of the other sides. But if people want to have a think about this, I'm quite happy to chat to you for a couple of minutes just to give people a bit of time to think about it.
Yeah, well, definitely I need some brain. I'll let my brain hasn't figured it anywhere near this. So I think people from what I've been seeing in the chat, they're much more on the ball than I am. So we'll let them have a think. So the first question, I think, same question I asked Ben, is Halloween, what mathematician would you dress up?
So I'm trying to remember, because when I was doing my PhD in maths in the maths department, we had the most incredible Halloween parties. And every year people kind of increasingly dressed up as ridiculous things, including not just like people, but like mathematical concepts. And I think my pinnacle of Halloween maths costumes was when I came as the sandwich rule. Which is this really nice result about functions that converge. But I was dressed as a witch, but with sandpaper, hat and outfit. And the broomstick that I was carrying was a meter rule. So I was the sandwich rule. And for most of the evening, it was people just going, wait, no, don't tell me. I'll figure out what you are. Hang on. And then like an hour later going, no. You're going to have to tell me. But that was a sign that I had been successful at dressing up as a mathematical concept for Halloween. But yeah, in terms of actual mathematicians, I think probably Mariam Mirzakhani is a fantastic role model mathematician, very, very sadly died, but did research in topology, which is the kind of maths that I did for my PhD. And I kind of think of her as being a sort of like a very strong role model for kind of mathematicians coming through the same route that I did. So I think she's incredibly cool as well. She's some really nice bits of maths and just totally represented. So that will be my Halloween costume.
Well, I would say what you've been up to, but it's this. It's basically, I've got this list of questions.
It's largely been this. I mean, yeah, I think. I mean, I guess, I don't know if anyone knows me, it's not just this, which is terrifying. So I've been doing various bits of maths lecturing for universities. I have been teaching at Sheffield Hallam University earlier this year, and I'm now doing a little bit more teaching there in a different department, teaching a maths course, which is really good fun. It's really nice to kind of work with university level students and talk to them about maths at a level that's kind of, you can really get into stuff with people at that level. Not that it's not fantastic to talk to young people and talk to general audiences about maths and make everything nice and accessible, but I can really just walk into a room and go, this is great, isn't it? And they're like, yes, and then we can talk about some really nice stuff. So I've been doing that, and that's been kind of fun. I've been planning with James Grime, who was on 2 people ago. He is terrible at marketing, I have to say, because when they said, have you got anything to plug? He was like, no, not really got anything in particular. So me and James are planning some events at the end of November, which are going to be like, because the original plan was we wanted to do like a summer school, like a cool maths people summer school where kids could come and spend, a week or half a week or something, and we could run some workshops and do some fun stuff. And obviously that's all been completely scuppered by the idea of COVID. So we're piloting a virtual weekend retreat, which is to say it's 2 half-day sessions on each of 2 days of a weekend. And we're going to have a small group. We're going to do some really nice focus workshops where we can really get into some interesting stuff. James is going to talk about some graph theory like he did in his little trick bit. I'm going to talk about topology because it's my favorite thing. And we're going to just sort of get really into some stuff and have fun. And there's 2 sessions, one for years 7 to 11, which will be called Key Stage 3. No, years 7 to 9, which is Key Stage 3. Yeah, and one for years 10 to 11, which is Key Stage 4 or whatever the relevant age groups are. Yeah,
I'm not sure.
I think it's 11 to 14-year-olds in the younger group.
11 to 14 is free. It's Key Stage 3. Yeah.
Yeah, that's the one. I can remember. Oh, there's so many numbers. I'm very tired. Yeah. And we've got 2 separate sessions, so they'll be covering the same content, but just at a slightly different level for the 2 different groups.
Yeah. There are some links on the chat as well. Yeah, those come up.
So that should be fun. Hopefully, if we can get some people along.
And so if I'm one of the things that Mark Watson, one of the charities Mark Watson is supporting is Comedy Support Act, and which is supporting comedians, other performers who have no income at this time. And one of the big losses that all the performers, people that I know have had, is we've missed Edinburgh this year. And it's looking like next year's Edinburgh Festival is a bit of hit and miss whether it's going to be a full thing or not. And I was planning to go up there with a play trying to explain quantum physics through karaoke.
Amazing.
And so if you had to write a play about a bit of maths, what would you write it on?
Ooh, that's really good. That's a good question, because there's so many of these sort of fantastic stories that just kind of. So what? In fact, I've recently written a new talk that I've done in a couple of different places that's about the story of a particular piece of maths. And obviously, because I'm doing it as a maths talk, I'm literally just explaining some maths as I go along. But it's the idea of kind of finding the sums of numbers, so triangular numbers that are sums of 1 + 2 + 3 + 4, and then sums of square numbers and sums of cube numbers. And it's this really fascinating story that goes all the way back to kind of Pythagoras and ancient Greece, and goes through via, China, India, all of these different places all across the world, brings you to sort of Renaissance Europe. And then Ada Lovelace gets involved and starts calculating Bernoulli numbers, and then it's now connected to the Riemann hypothesis, and it brings you all the way through to modern maths. So I wonder if that would make a really good sort of theatre piece where the maths is the thing that connects all these different stories.
Definitely sounds. I mean, you're so busy doing basically everything. It's just sit down and work into a play.
I'm slightly worried I'm going to have to do that now. You said it. It's actually quite a good idea. Anyway, I'll file that away.
Well, I'm assuming you. Well, if you want to go to Edinburgh, I think we've got a year and a bit to work.
We won't be touring theatres anytime soon, I guess. Yeah.
Which is all the more reason why people should be donating. If they go over to that's probably the right one. The donate.watsonafun.com and choose a mathematical amount. It helps, or a non-mathematical amount. Well, everything's numbers. It doesn't matter. any numbers.
All numbers are mathematical. That is definitely true.
Yeah, algebra not so great, but they'll definitely know it came from this stream if it did.
Yeah, well, I strongly recommend people donate £N. That's my recommendation.
Do you think
where N is greater than 0?
Do you think we've given people enough time to think about
So yeah, there's a few people seem to be looking about it and chatting about it. Some people definitely know how it works. And what I might do is I might point something out. So there is a method that I'm using here, and I can use it to add up these four-digit numbers. But I could also, because these are all just sticks with numbers on, right? They've got because I could put them in any arrangement. It kind of doesn't matter which order or which way round I put them. I can actually just take 3 of them, right? And if I've got 3 of them together, I've got 4 3-digit numbers, and I can tell you that the total of those would be 2,432 just by looking at it immediately. And I can even take away another one, and I've got those 4 numbers, 49, 52, 34, and 97, and the total there would be 232. And I can even take away all of them and just be left with 1. And I could tell you, and I'm sure anyone could probably add this up in as much time as it would take me, that the total of those 4 numbers is 22. And this is all using the same technique because it works all the way down. And it turns out there's one particular thing about these that is the key to the trick, and that is the 3rd row. Okay, so this is the important row on the trick, and that's a clue that I'm going to give people. So if I bring these other ones back in so you can see some of the numbers. If you look at the 3rd row, in particular, if you look at all the numbers that aren't in the 3rd row, there's something interesting about each of these 4 sticks. So on this one, for instance, the numbers that are not in the 3rd row are the 7, the 8, and the 3. And if you add those together, you get 18, right? We've got 7 and 3 is 10 plus another 8. And in this column, we've got, again, a 3 and an 8 and a 7, add up to 18. This one, we've got a 4, a 5, and a 9, which again add up to 18. And if you look at any of the faces on any of the sticks, they will all add up to 18 if you just ignore that 3rd row. And that's the crucial piece of information here. And I think, to be honest, it's quite a nice little kind of puzzle to work out how this goes. Because especially if I take away 3 of them and just look at that one, if I know those 3 add up to 18, and I would tell you that the total there would be 22 because I just need to add on the 4 as well, right? That seems pretty obvious. Here, I would tell you the total is 222. And here I would tell you that the total is 2,922. And if I bring this one in and put it in on this side, the total there would be 29,241. So I don't know if that's given people watching a bit of information about what I'm doing here, but it's a really nice little trick. And I say the video that I've done for Numberphile goes a little bit into more of how this works. I've also, I think somewhere in the links that the behind the scenes people have got, I've also put in a link to a printable version of this, because apparently this is my hobby, is producing PDFs of things. If something comes near me, I'll produce a PDF of it. So it's like a little printable thing where you can cut out the shapes and then fold them down 4 sort of creases vertically and wrap them around into a little tube, and you'll have a set of these with the numbers on them arranged in the exact same way, so that you can have a go at showing this trick to other people. Obviously, you can get yourself a nice metallic set. These ones are available on internet websites for purchase. If you look for Mental Logs Magic Trick, you'll find examples of these, and they're at various different price ranges. So these metal ones are, I think, in the region of about £15, which is quite a lot for one magic trick, but I've used them a lot, so I've got value out of them. But if you're not prepared to invest, then the printable ones are probably just as good. And yeah, that's a little bit of, I'm not going to give away the whole thing, but I'm going to point out those interesting facts about the numbers and see if that gives anyone a clue.
Yeah, remember, I think it is of your site that managed to find the PDFs for the 1 cup fold, for the one cup fold letters, is it?
Yeah, so I was talking about this earlier today. I was on, was it today? Who knows? It's hard to tell. It was a while ago. But when I was on earlier, when our guest was Tom Scott, and I was here to present a trick for Tom Scott, I was showing him the fold and cut stuff. I did a paper star and various other different shapes, and I cut out some letters. I was talking about this, and I worked out a way to fold up a piece of paper so that you can make one straight cut and cut out any letter of the alphabet. I'd kind of worked out a fold pattern for each of the 26 different letters of the alphabet. And having done that, having spent hours, sat working out all of these things and practiced them and learned them, someone pointed out to me that there was already a PDF of that, which is infuriating, because if anyone's going to make that, it should be me, right? That's my thing. So that someone else has already done this. So I found it and put... I now sort of point people to that website where the PDF is if they ask me how do you do the letters of the alphabet, because I've not yet encoded mine anywhere particularly well. I was saying to Tom earlier that there's now a font that with like the person who originally did the proof of the theorem contacted me and said, I collect fonts. Would you like to send me your folding patterns for the letters of the alphabet and we'll make a font? So there is a PDF of that on Eric Domain's website, but the actual fold patterns that I use for my letters are in here. They're just inside there.
Yeah, that was something they had. Because I used a couple of times. I've been forced into running origami clubs, and or and that's sort of one of these things that I'll just sort.
And he worked it out and he figured it out for himself, and he was really pleased, and he had this really nice moment of like, oh, you know, I figured something out, I realized what I need to do here, and I think he enjoyed that. I guess he enjoyed that as a thing. I think there's some people saying there's no sound. I don't know if that's
I can hear you.
There's no sound. Yeah, now. We can hear each other. Yeah.
There's somebody saying better now. Oh, back. It's back. No sound. Back.
Ah. Well, anyway, I was just talking about what happened this morning at 5 a.m. So if you want to know, rewind the live stream or look for the first half of the live stream, which is also on my YouTube channel. You can find, go to 5 a.m. or whatever it was. Was it 5 or 6, 7? Sometime this morning anyway, when I was talking to Tom Scott, and you can see how that all went down.
Because it's like I used to use, well, one of the things I did manage to make was sort of templates for flexagons. And so I had myself a Photoshop template so I could put whatever pictures I wanted in there. And so that's another stealth way. Do you sort of, any advice for the parents and maths teachers looking at that sort of, or just teach in general? Because obviously part of the national curriculum and stuff is you've got to look at numeracy in your lessons. Any good stealth way of putting maths? What's your best sort of stealth maths thing?
I mean, I sort of slightly dislike the idea of stealth maths in the sense that I feel like it's good to be upfront about the fact that what you're doing is maths, especially if it's something that people are going to enjoy and come away from thinking positively, which, you know, I hope is what people think when I come and do activities and workshops and things. But, you know, if they are very clear that, you know, I'll come and do some magic tricks and I'll say, I mean, I don't always wear the hat, but sometimes, and I'll say, you know, we're going to do some magic tricks, but this is all maths. Like what we're doing here is using the same skills that you would use to do maths. And I think it's really important to point that out to people, because if they go away, they make that kind of positive association with maths, I guess. Like they think of that as being something that maths has given to them. And, you know, there's been a few people on the stream throughout the day today have been saying, you know, this was the thing that made me realize that I was interested in maths. I think it was James was saying that he was doing some of the parabola stitching with straight lines. And he was like, oh, if that's maths, then maybe I do like maths. I think that's a really nice sort of insight that you can give people. But yeah, at the same time, you can't just expect people to be interested in something because you think it's interesting. And like it's always really nice to be able to give people a reason to be interested in something or a hook. So things like really hands-on activities like paper folding, origami stuff is really nice, especially if you've got someone who's kind of maybe a bit worried about maths, like they're concerned that if they try and do something they'll make a mistake. That can often be a barrier to people to even try. Whereas if you say, oh, we're just folding bits of paper, they'll go, okay, well, I'll have a go at that. And then before you know it, they're thinking in 3D and they're constructing things and they're following simple written instructions and they're finding lines of symmetry and things. And, you know, it's suddenly they're just doing all this stuff without feeling like what they're doing is maths. So there's, I guess, a balance to be struck between, you know, dressing something up and, you know, doing some juggling and saying, oh, it's maths because there's 3 things. And I'm absolutely not saying that's what Colin Wright does. Colin Wright's juggling talks are full of incredible math stuff. But you do sometimes see things that are just like, oh, you know, play this computer game and learn how to add up numbers. And it's like, come on, there's so much more interesting about maths that you can learn and that you can enjoy and play with, that, you know, the maths itself is the thing that you're playing with, not, you know, some veneer that you put on top of it. So somewhere between hands-on activities to make things engaging, but also make sure that you are actually doing maths and that everyone knows it.
Yeah, yeah. I mean, it's all making sure that that mistakes are allowed. It's sort of the biggest sort of. I think we've all made mistakes in our maths at various points.
Mm.
I yeah. Well, I think I've been sort of existentially looking at sort of the US election. I'm just trying to, but the maths involved in modelling that, and this sort of, and the amount of podcasts I've been listening to on sort of maths modelling, and then everything sort of,
yeah,
the amount
everyone's mathematical modelling at the minute. There's so much modelling happening right now. It's terrifying.
Yeah,
that and viruses, everything.
Yeah, it's a great time for working out how to maths model. So I'm just wondering, are we ready for our next person?
I mean, I'm quite happy to play the video thing into the feed if that's helpful for you. You can do the fun animation if you would like that.
Oh, yeah, I can't do the fun
here.
animation.
Go on then. All right, we're watching the 24-hour Maths Magic Show, and I can also put the donation link on as well. I might have to just lower myself down a little bit. There we go. That's the donation link there above where I am here.
And so, yeah, any kind of mathematical number, as I was saying, but yeah, any kind of. But if you can tie it to some sort of rational number, pi, tau, or something like that, phi, then
I mean, yeah, just
it's great
if you
the decimal place. Yeah.
Yeah, if you donate £1, then £2, then £4, then £8, and just keep going. See how you get on.
Yeah, and rational numbers you can just keep moving the decimal point to wherever you want. So
yeah,
it doesn't have to be £3.14. It could be £31 and carry on if you're feeling that generous. So next up, thank you for this. Thank you for putting the whole thing on. And if we want to find out any more of your videos, where can we look online or other stuff?
Yeah, I'm on Twitter at Steckles, and I have a website at katesteckles.co.uk, which has a terrifyingly long list of things that I do, where you can find out some bits and pieces that I've been working on lately.
Okay, well, thank you to Katie, and probably see you again quite soon.
Yeah, I'll be back on the feed in a terrifyingly short amount of time, but thank you very much, and have a nice rest of your bit.